Hi dear friends, in the last part of the video we particularly discussed about the last unit entitled as chemical thermodynamics, in which we discussed various colligative property and how these colligative properties are related to the concentration of the solution, means the concentration of the solute or the number of solid particles, and how these are used to determine the molecular weight of unknown solute. So all these things that we discussed in the last part of the video. Dear friends, today in this part of the video, we are going to talk about the last part of our syllabus, and that is entitled as molecular spectroscopy. Dear friends, spectroscopy is the technique which is used to predict the correct structure of the molecule, and it is defined as the study of responses given by the molecule whenever it is exposed to some kinds of the radiation. Then that study of responses is called as spectroscopy, and if these studies are carried out for the molecule, then it will be called as the molecular spectroscopy. So it indicates that whenever any molecule is exposed to some kinds of electromagnetic radiation, then the molecule gives some responses, and the study of that responses is called as electromagnetic. It's called as molecular spectroscopy. So what is this electromagnetic radiation? These are a simply form of energy. These are simply form of energy which are transmitted through the space at a constant velocity of light, and that is 3 into 10 raised to 8 meter per second. And these radiations are known to have the dual character, that is wave character as well as particle character. This wave character and the particle character of these radiations are supported by various experiments in which we are not interested here, but it is also observed that the wavelength of this radiation is inversely proportional to the frequency of the electromagnetic radiation, and these are related by the equation lambda is equal to c upon mu. This c is the velocity of light, mu is the frequency, and lambda is the wavelength. And these are some various types of electromagnetic radiation. And all these electromagnetic radiations are grouped together in the form of spectrum called as electromagnetic spectrum. And if you observe, these are the ranges of this radiation, these are the ranges of frequency of these radiations. And here, if you observe this from this table, these are the gamma radiation which are considered as, or these are the highly energetic radiation, and radio frequency of the radio, these are the lowest energetic radiation. So this is regarding with the electromagnetic spectrum. As far as concerned with the molecular spectroscopy, in the molecular spectry, the term dipole moment is very important. Whether the molecule is having dipole moment or not, on the basis of this, definitely it will show the particular type of the spectroscopy that we will discuss later. But before this, what is dipole moment? We should know what is dipole moment. Generally, it is observed that every molecule is composed of positively charged nuclei and negatively charged electrons, in such way that the whole molecule is electrically neutral. It means that the number of positive charge in the nucleus are always equal to the number of negatively charged electrons which are revolving around the nucleus. And there are two different ways in which the arrangement of these particles can take place or can be possible. In the first case, if the center of gravity of positive nuclei coincides with the center of negatively charged electrons, then such type of molecules are called as a non-polar molecule, like hydrogen, chlorine, oxygen. And in this type of the molecule, the two atoms are having equal electronegativity. In the second case, if the center of gravity of positive nuclei does not coincide with the center of gravity of negatively charged electrons, then the molecules will be called as the polar molecule. And the example is Cl2, ammonia, methyl chloride, etc. And in this type of molecule, the atoms of such molecules will have the different values of electronegativity. Here you can consider the positive charge having plus q, minus charge indicated by minus q. These are separated by the small distance r. In this case, then if r is the distance between these two charges and q is the magnitude of these charges, then the equation for the dipole moment will be equal to q into r. So this is simply the product of charge and distance of separation between the two charges. It's very simple to define regarding with this. So here for the dipole moment, the two atoms must have different electronegativity. Then and then it is possible to have the dipole moment for this molecule. Example is HCl. In this case, definitely hydrogen and the chlorine are having the different value of electronegativity. And the unit of dipole moment, the CGS unit of dipole moment is dBi. Remember this, very important, and it is indicated by capital D. So this is the CGS unit of dBi, indicated by capital D. This unit named after the name of this physical chemist Peter Debye, who has discovered this. And here dipole moment is the multiplication of electron charge and the bond length. Here after this, the in the SI system, if we try to correlate between the dBi and the coulomb meter, then definitely this 1 dBi is equal to 3.36 into 10 raised to minus 30 coulomb meter. So this is the very important regarding with the relation between this. What is the bond moment? Bond moment is simply the dipole moment of a bond is called as the bond moment. So any bond has some degree of polarity because of dipole moment, and the dipole moment or the polarity of that bond is called as the bond moment. Here you can see, here there are 3 carbon chlorine bond and 1 carbon hydrogen bond, and definitely the arrangement of this molecule is very important. But if molecule is symmetrical and having identical bond, any molecule is having symmetrical structure with identical bond, then its dipole moment will be 0, and this molecule is called as non-polar molecule. It's here the example is CCl4. So here, and in the molecule, in the other molecule as a whole is non-polar. If the molecule is asymmetrical with a different bond, if one of the bond is in this molecule is replaced by another atom like this here, CH bond, then the molecule becomes asymmetrical and it will have some value of dipole moment, and the molecule is called as the polar molecule. It's very simple to define. There are some bonds with their bond moment. Definitely here HF bond is having the greater bond moment with the dipole moment than HCl having 1.1. This dipole moment is very important in order to decide, in order to elucidate, in order to determine the correct structure of the molecule. If the molecule is having more than 2 or more than 3 possibilities of their possible structure, then the correct structure can be identified with the help of the concept of this dipole moment. For example, here the water molecule, you know very well, water molecule there are 2 hydrogen and 1 oxygen. The first possibility is that all 3 atoms are in one line linear structure and another structure in angular structure. But in the linear structure, one bond moment is cancelled by the bond moment of other bond, and whole dipole moment or the dipole moment of this molecule is expected to be 0. But in this case, the 2 bond moment does not cancel each other and they adds vectorially, and it will have some value of dipole moment. But actually in practice, whenever the actual dipole moment of H2 molecule is studied, then it is observed that the H2 molecule shows a dipole moment of 1.85 dBi. Hence water exists in angular structure and not in the linear structure. This is very important to note here. Because of its angular structure, the water molecule shows 1.85 dBi dipole moment. Another example is the carbon dioxide and the sulfur dioxide. Here it is observed that the carbon dioxide shows a 0 dipole moment, and this is only because of the linear structure of the carbon dioxide, in which the bond moment of one carbon oxygen bond cancel the bond moment of another carbon oxygen bond, and that's why it has a 0 dipole moment. So it not having the angular structure. Carbon dioxide has the linear structure in which the 2 bond moment will cancel each other, while the sulfur dioxide molecule shows 1.63 dBi dipole moment, indicating that the 2 bond moment of sulfur oxygen bond does not cancel each other, therefore it does not having the linear structure, and it shows such type of angular structure in which the two bond moment adds vectorially shows the value of 1.623 d by. Another example in which the concept of dipole moment is again very important to identify the correct structure. One is the BF3 molecule. Here, whenever the BF3 molecule is studied or the dipole moment of BF3 molecule is studied, then it is found that, or it is observed that it has a dipole moment 0. It has the 0 dipole moment, and this is possible only if the three BF bonds are arranged symmetrically around boron atom in the same plane, and this is possible in this type of the structure only. Otherwise, definitely it will not have the dipole moment 0. In this case, each dipole moment is cancelled by the dipole moment other two bonds, and that's why here this BF3 molecule, boron trifluoride molecule, shows the trigonal planar Morse structure, and this is and that's why BF3 molecule is having 0 dipole moment. On the other hand, if we talk about the ammonia molecule, then the ammonia molecule shows 1.47 d by dipole moment. It indicates that in the ammonia also there is one nitrogen, 3 hydrogen. These are not symmetrically arranged in the plane, in the same plane, and it is indicated, it is explained by means of its pyramidal structure. The actual structure of the ammonia molecule looks like this, in which the 3 hydrogen NH bonds are in the downward direction, and the top of the nitrogen there is one lone pair of electrons, and that's why it is observed that this lone pair of electrons also makes a large contribution in the net dipole moment, and that's why the net dipole moment of the ammonia molecule is not 0. It shows 1.47 d by. So this is the exact structure of the ammonia molecule, in which it will have some value of dipole moment, and this structure is called as a pyramidal structure. Another example is the CH4 methyl molecule. It is observed that this methyl molecule also shows a 0 dipole moment because of its symmetrical structure, in which the dipole moment of this 3 CH bond is cancelled by the dipole moment of 4th CH bond having the 0.4, because of the angle between them, definitely. And this is a structure called as a tetrahedral structure. So in the tetrahedral structure, each bond moment is cancelled by the bond moment of other 3 bonds. That's why it shows a tetrahedral structure. Definitely here the dipole moment will be 0. Another thing, here the dipole moment can be used to identify the difference between cis and trans. Here you can see the cis and trans isomer of dichloroethylene. In the cis dichloroethylene, the 2 chlorines are on the same side and 2 hydrogens are on the same side. Definitely the bond moment of this Cl bond is not cancelled by the bond moment of this, and that's why it has the dipole moment of 2.88 d by. But in the trans isomer, the 2 similar or the identical bonds are exactly in the opposite direction, and that's why the bond moment of this bond is cancelled by the bond moment of this bond, while the bond moment of this bond is cancelled by the bond moment of this bond, and the net dipole moment of this trans isomer of dichloroethylene molecule will be 0. So in the cis isomer, similar atoms are arranged on the same side, hence bond moments will get increased, and the molecule will possess some value of dipole moment. Whereas in the trans isomer, these are present on the opposite side, and therefore the bond moment will be equal in magnitude but opposite in direction, hence the net dipole moment will be 0. So always remember that trans isomer always having 0 dipole moment, while cis isomer do not. Again, this dipole moment is also used in order to identify the different isomers of this 1,2 disubstituted or that is disubstituted benzene molecule. So let us consider the ortho, meta and the para isomer. Actually, benzene is the symmetrical planar linear structure, hexagonal structure, in which the dipole moment is 0. But if we will consider the derivative of this, particularly dichlorobenzene, then we will come to that its ortho isomer, para isomer, and the meta isomer having the different dipole moment. It is observed that ortho isomer of dichlorobenzene is having 2.6 d by dipole moment, or meta isomer having 1.5 d by, while the para isomer having 0 dipole moment. Why this is so? because the net dipole moment of this isomer this molecule is calculated with the help of this under root of mu1 square plus mu2 square plus 2 into mu1 mu2 into cos theta, and mu1 mu2 these are the bond moments of two CCl bond, and theta is the angle between the two substituents. Here you can see this is the angle, that is, you can see it is 60 for the ortho isomer, for the meta it is 120, and for the para it is 180 degree, and this is calculated with the help of this formula. It's very simple. If we calculate this by putting, because here the bond moment of each bond can be substituted here, and the calculated value can be compared with the experimental value, and it was observed that the above structures of ortho meta and para isomers stand conform, and dipole moment of ortho meta and the para isomer provide the method for distinguishing between the different derivatives of benzene. So this is an important thing. So if we get the 2.6 dBi, it indicates that the molecule is ortho isomer. If you are getting 1.5 dBi, it indicates the meta isomer, and if you are getting 0 dipole moment, it indicates the para isomer. Because in the para isomer, the bond moment of this bond is cancelled by the bond moment of this, and definitely that is this cos 180 will be again 0. This term will be again 0, and this bond moment and this bond in the opposite direction. It doesn't matter. So here, besides or from other than the structure of the molecule, dipole moment also provides the other information, and the first information regarding the polarity and non-polarity of the molecule. So here we can conclude from above discussion is that if any molecule is having some dipole moment, it means it is having some value of dipole moment, then the molecule is called like the polar molecule. It's very simple. And if a molecule is having 0 dipole moment, then the molecule is called like the non-polar molecule, like hydrogen, nitrogen, oxygen, while the polar molecule is to ammonia, HCl, like this. And this dipole moment also gives the information of degree of polarity. If the dipole moment of molecule is having high value, its degree of polarity will be also high. It's very important. So here HF molecule is having more dipole moment 1.91 dBi, and HCl is having 1.08 dBi. It means that HF molecule is more polar than the HCl molecule, and it also gives the information regarding the polarity of polyatomic molecule. So here it is also observed that in case of molecules with a symmetrical shape, the dipole moment is found to be 0. So if the molecule is symmetrical, then it will be nonpolar. In this case, the polarity of one bond will be cancelled by the polarity of other remaining bond. So if the molecule is symmetrical, then it will have the 0 dipole moment. And if the molecule is unsymmetrical, in such case the molecule is polar, because the polarity of one bond does not able to cancel the polarity of other remaining bond, and it means that the bond, if the molecule is unsymmetrical, it will have some value of dipole moment, and if the molecule is symmetric, then it will have the 0 dipole moment. So here the example of unsymmetrical molecule, in which definitely the one bond moment does not cancel the bond moment of other bonds, and that's why these molecules are having some value of dipole moment because of their asymmetrical structure. So this is very simple regarding with the relationship between dipole moment and the structure of the molecules. We are able to predict the structure of the molecule based upon the dipole moments. So dear friends, in this part of the video we try to discuss about the basic concept in the molecular spectroscopy, dipole moment, and how this dipole moment is used to determine or to identify the correct structure of the molecule whenever more than two possibilities are there. And this is all about this lecture. So in the next part of the video we will try to discuss about the different types of the spectroscopy, particularly how the radiations are able to produce the different responses in the molecule, and that is studied with the help of different types of the phenomena shown by means of a molecule whenever these are exposed to some kinds of the or different types of the electromagnetic radiation. So thank you very much.